Welcome back. Hope you love if statements because this video is full of them. I'm going to teach you about logical operators, which, like comparison operators, can be used in the condition of an if statement. Let's say we want to determine whether a number is between 1 and 10 inclusive. We can do that with an if, elif, else statement. Notice that two of the branches have identical code. This is a little silly. Turns out we can combine them into a single branch using the logical operator OR. Now, if either expression is true, if the number is less than 1 or if the number is greater than 10, the first branch will execute. Here are the three logical operators we're going to discuss in this video: and, or, and not. Let's take a closer look at not first. In this case, not y evaluates to true because y is not true, so this branch will execute. X and y evaluates to false because it is not the case that both x and y are true. This branch will not execute. X or y evaluates to true because at least one of x or y is true, so this branch will execute. The expressions on either side of the OR operator just need to evaluate to booleans, which means they can also be comparison expressions. In order for this branch to execute, x has to be greater than 50 or y has to be greater than 50. Let's work through an example program step by step. In this program, we will ask the user what their role is in school. We will use that role to determine whether or not they get a classroom key. If they are a teacher or an administrator, they get a classroom key. If they are a student, they do not get a key. And if they are none of the above, something's wrong. This table shows the values of various Boolean expressions given the values of x and y. I'll let you study this slide on your own. You can visualize logical operators using Venn diagrams. Imagine that the variable a represents whether or not a dart landed in circle A, and the variable b represents whether or not a dart landed in circle B. This region represents a being true. In order for the expression on top to evaluate to true, the dart must have landed somewhere in the circle A. Note that the dart may have also landed in circle B, or it may not have. This region represents a being false, which makes the expression not a evaluate to true. Anything can be green as long as it isn't in A's circle. The word not basically means make everything green that wasn't green in the original expression. This region represents B being true. And this region represents B being false and not B being true. This region represents both A and B being true, which makes the expression A and B evaluate to true. The word and basically means make everything green that was already green in both original expressions. This region represents when it's not the case that both A and B are true. So the dart could have landed in circle A, or it might have landed in circle B, or it might have landed in no circle, as long as it didn't land in both circles. This region represents either A or B being true, which makes the expression A or B evaluate to true. The word or basically means make everything green that was already green in either original expression. This region represents when it is not the case that A or B is true. This means that the dart cannot have landed in either circle regardless of overlap.